Welcome to Pramod YouTube channel. Today we discuss effect of substituents on reactivity and orientation of benzene derivatives towards electrophilic aromatic substitution reaction. In order to understand this broad title, first we have to know the meaning of substituents. What are various types of substituents are present? So what are the substituents that are present here? Substituents means it is nothing but a functional groups. Substituents means they are nothing but a functional group. So substituents are the functional groups. What are functional groups? It is an atom or group of atoms which are responsible for the physical and chemical properties. So we have to understand what are the different substituents which are present. What are different substituents? Substituents are nothing but functional groups which are attached to the benzene ring. So those are called as any functional groups. What are these functional groups? It is an atom or group of atoms which are responsible for the physical and chemical properties. For example, if you take the substituent like hydroxyl, so it is an hydroxyl, dash OH is an hydroxyl group. So it is one of the functional group. So by seeing this functional group, we will come to know the physical properties. So hydroxyl are soluble in water. Okay, means alcohols are soluble in water. You know that alcohols are soluble in water. So hydroxyl group is nothing but it is an alcohol functional group. So alcohol functional group determines the physical properties. Physical properties means what? ROH, alcohol is there. Alcohol is soluble in water. So functional group are the atom or group of atoms which is responsible for the physical and chemical properties. So the chemical properties of any compound depends upon the functional group. So chemical reaction, what type of reaction does hydroxyl will undergo? So those chemical reactions are also known by the functional group. So you understand the term functional group. Functional group is an atom or group of atoms which determines the physical and chemical properties of the compound. Various types of substituent we will understand first. So there are two broad class of substituents. One is electron donating group, electron donating groups, electron donating groups, electron withdrawing groups, electron withdrawing groups. So what are these electron donating groups? Again, the substituents electron donating groups can be again classified as strongly electron donating group, moderately electron donating group, and weakly electron donating group. What is this strongly electron donating groups? Strongly electron donating groups examples are hydroxyl group or hydroxyl substituent, NH2 group, that is primary amine, okay, or else it may be a tertiary amines. So all are strongly electron donating group because on oxygen there are two lone pair of electrons. So on nitrogen one lone pair of electrons. They are capable of donating the electrons very strongly. That's why they are called as a strongly electron donating group. Group means it is alkoxy group, methoxy group, ethoxy group, propoxy group, etc. So they are the moderately electron donating groups. Now what are weakly electron donating group means? You know that methyl, ethyl, propyl, etc. This all comes under a categories of a substituent called as electron donating groups. So these are the substituents which are present on the benzene. If the substituents are present on the benzene, so what is going to happen? Whether the rate of reaction increases or decreases, we will discuss later. So electron donating groups are categorized into three subclasses: strongly electron donating, moderately electron donating, and weakly electron donating group. So electron withdrawing groups are those groups which are having a tendency to draw the electrons. Electron donating group means they donate the electrons, they give the electrons. But electron withdrawing, by the name itself indicates, they will withdraw the electrons. So they are called as an electron withdrawing groups. So these electron withdrawing groups are of different types we can get. Mainly the electron withdrawing groups are halogens. So halogens like chlorine, bromine, iodine, fluorine. So all the halogens are electron withdrawing groups. Now other groups like nitro groups, nitrile groups, nitro group, nitrile group, sulfonic acid group, SO3H. So this all comes under a class of electron withdrawing groups. So electron withdrawing groups are all the halogens, nitro group, nitrile group, that is cyano group, and the sulfonic acid group. These all are electron withdrawing groups. Now we have to know two important terminology to understand further about the title. One is activating group, the other is activating group, the other is deactivating groups. Deactivating groups. So far we have discussed various types of reactions. In my previous video, if you follow, we have discussed all important 5 types of reactions of benzene. Now, what are the groups that will increases the activity? What are the groups that will decreases the activity? So we know that benzene undergoes electrophilic aromatic substitution reaction. So to increase the electrophilic aromatic reaction among electron donating, electron withdrawing group, which groups, if you keep on the benzene, increases the rate of reaction? So those groups are called as an activating groups. What are activating group? These are the groups which increases the rate of reactions. These are the groups which increases the rate of reaction, and these are the groups which donate the electrons to the ring and helps in the resonance stabilization. So I have said that activating groups are those groups which increases the rate of reaction. To which reaction? Electrophilic aromatic substitution reaction. Now which type of groups will increases the rate of electrophilic aromatic substitution? Means effect of substituents. Which substituents will increases the rate of reaction? The substituents which increases the rate of reaction is called as an activating group. Now which is increases the rate of reaction means all electron donating groups increases the rate of reaction, and this electron donating group are called as an activating groups towards the electrophilic aromatic substitution reaction. Very simple. This electron donating group, now you understood the electron donating group. This electron donating group increases the rate of reaction towards the electrophilic aromatic substitution reaction. So what are deactivating groups? Deactivating groups are electron withdrawing groups. So electron withdrawing groups are also called as a deactivating groups towards electrophilic aromatic substitution reaction because they decreases the rate of reaction. This will increases the rate of reaction. This will decreases the rate of reaction. Any groups which decreases the rate of reaction is called as a deactivating groups. So which groups deactivates electrophilic aromatic substitution means the groups electron withdrawing groups. Electron withdrawing groups decreases the rate of reactions. So activating group means increases the rate of reaction. Now why they increases the rate of reaction means they tend to give the electrons to the ring. They tend to give the electrons to the ring. As a result, they will stabilize the ring or stabilizes the benzene and increases the rate of reaction. Why deactivating group decreases the rate of reaction means, that is electron withdrawing group, they withdraw the electrons. When they withdraw the electrons, the ring will not be stabilized. The ring will not be stabilized, hence they will deactivate the ring. They are destabilizes the ring, hence they are called as deactivating groups. Now what is an effect of activating groups? Activating groups are nothing but electron donating groups. Deactivating groups are nothing but electron withdrawing groups. Now how does this will increase or decrease the rate of reaction? I will take one example of each and I will let you know the things. Now in the activating groups, again we can tell about orientation. Orientation means where they orient. So activating groups. So we are talking about activating groups. Activating groups are those groups which increases the rate of reactions. So rate of which reaction? Electrophilic, aromatic, substitution reaction. So activating groups means, what are those activating groups? Activating groups are the groups of electron donating groups. You have seen the electron donating groups. Where they orient? They orient at ortho and para position. Which positions they orient? Ortho and para positions. This is orientation. This is orientation. This is activating substituents. Substituents are nothing but electron donating groups. They are orient at ortho and para position. So hence we call it as ortho or para director. What is that meaning, ortho or para director? We will discuss little bit later. Now deactivating groups. Deactivating groups are electron withdrawing groups. Electron withdrawing groups. They are only meta directors, means they orient towards the meta position. If deactivating groups are there, they will attack, electrophile will attack on the meta position only. You remember just orientation. Activating groups are those groups which increases the rate of reaction by donating the electrons. They stabilizes the ring. How they stabilizes the ring, I will explain you with the example. They are ortho and para director. Deactivating groups means they are electron withdrawing groups. They are the meta directors. They orient at a meta position. Why they orient at a meta position? I will give one example and explain you in a clear manner.